Okay, we're going to talk about classifying functions, and I want to talk about the different type that we'll be looking at in Algebra 1 this year. Last year you started out with a linear function, which is just basically, it's a straight line, okay? You got a straight line. It's only got plus, minus, multiply, or divide in it. There's no square roots or absolute value, no absolute value, no square root. There's also no variable in the denominator. Demon denominator. And like if you had 3x equals 2, that's not a function. Okay. Also, the largest exponent is 1. Okay. So you won't see any exponents because exponent 1's invisible, right? So you won't see any like x squares, x cubed, or anything like that in a linear. The next is quadratic, and this is the one that we cover the most in Algebra 1. In fact, most of next semester is just all quadratics. All right, so quadratic, 2 is its highest exponent. All right, and the graph is shaped like a horseshoe. And it can be going down or it can be going facing upward. Your relationship with your x and y, it'll increase and then decrease, or either decrease and then increase. Okay, when you're looking at your how your y's go up or down. Let's see. All right, so that's going to be about the main thing for quadratic. Exponential, the exponent is x. All right, so you have a variable for your exponent, and it might look something like a equals b to the x, or 120 equals 0.5 to the x. Okay, and these are either going upward or they can be going downward. All right, but they're not, it's not both. They don't make a turn. Okay, so it's either going up or it's either going down, and this can kind of be flipped over also. All right, an absolute value, it has the absolute value bars. Okay, that would be an absolute value, and its shape is a V. Okay, so the V is either going up or it can be going down. Okay. Let's see. All right, so those are the 4 types of functions we'll be looking at. We'll be able to identify them by the graph today. So this one's a straight line, this one's a horseshoe, this one's going either up or down, and this one is the shape of a V. Okay. Example of the equations would be like y equals 2x plus 4, or y equals 3. This is slope-intercept form, if you'll remember. Standard form was like 2x plus 3y equals 12. And then we have like point slope form. Y minus 2 equals 3 times x minus 1. Okay, so all of these will graph a straight line. If you notice, there's nothing other than plus, minus, multiply, or divide in it. There's no square roots or no absolute value, and our greatest exponent's 1. And there's not a variable in a denominator. So that means it's linear, it's a straight line. A quadratic will always have a square in it. So it'd be like y equals x squared plus 2x minus 4. Okay, that's standard form of quadratic, or it could be in vertex form, which you'll learn about later on. It'll look something like that. All right, the key to this is the squares. All right, that lets you know it's quadratic. Absolute value, of course, you're going to be able to tell by the bars that it's an absolute value. Okay, an exponential, you're going to be able to tell by there's an x for the exponent. All right, so those are easy tells for that. Either, oops, sorry. Let's go to the next page. All right, so we're going to identify the graph. This one's a straight line, so it's linear. This one's a horseshoe, so it's quadratic.
Miss Crawford.
Ooh, sorry, y'all. All right, and this one's is kind of hovering, and then it jumps up exponentially, kind of like, remember they talked about COVID, just going up by multiples. This is exponential. And then it's a V-shaped, it's got a point, that's a vertex, so this is absolute value. Okay. All right, those characteristics for each function. This is the straight line, horseshoe, and it's a curve. It's either going up or down, not both, and a V-shaped. All right, compare and contrast. Well, linear is straight. It's the only one that's straight. The rest of them have a curve in it. All right, absolute value is the only one that's shaped like a V, has a point. Exponential is the only one with a one-way curve. And the quadratic's got a two-way curve, like a horseshoe. But technically, this has got a two-way curve, but it comes to a point and then turns. All right, this one just kind of goes like that. All right, let's go to the next page. All right, it says determine if each is linear, quadratic, exponential, absolute value, or other. All right, so this one has a square, so it's quadratic. This one has absolute value bars, so it's absolute value. This has a square root, so this today would be called other. It's a square root function. This has no exponents, and it's just plus or minus or multiply, so it's going to be linear. This has an exponent of 2, so it's quadratic. This has no exponents, and there's no variable in the denominator, it's linear. This has an exponent of 3, so this would be other, and it's called a cubic function. This has an exponent of x, so it's exponential. Exponent of 2, it's quadratic. Exponent of x, exponential. It's got a variable in the denominator, so it's not linear, and it doesn't have an exponent, so this is going to be other. And then this has an exponent of 2, it's quadratic. All right. Identify the graphs. It's a V-shaped, so it's absolute value. It's a horseshoe shaped, so it's a quadratic. It's a straight line, so line AR. This has a one-way curve, so it's exponential. It's a straight line, so it's linear, line AR. And this doesn't qualify for any of them, so today you would put other, but I will tell you that that's a cubic function. It has an exponent of 3. Okay. All right, so we can take a function and we can plug some numbers in for domain and make a table and then plot those points and make your graph. Now, looking at this function, 4x squared plus 7 minus 6x squared, I can tell you right off that it's going to be a quadratic, right? So it's going to be shaped like a horseshoe. Okay. So we're going to plug in some numbers for the domain. They did not give us any, but we're going to say that the domain is -2, -1, 0, 1, 2. Okay? That way your points are close in. All right? Now, if you have a graphing calculator, the easiest thing to do is to put this equation into y equals and then look at your table. And they've already done all the math for you. And when I plug it in, I'm going to get -1, 5, 7, 5, -1. Okay? If we plot those points, -2, -1, -1, 5, 0, 7, 1, 5, and 2, -1. So you have a horseshoe shaped, and it's a quadratic. Now, notice your numbers here, -1, 5, 7, 5, -1. Okay, it's kind of like they turn at 0, 7, right? And then the numbers start going back the other direction. Because it went from -1 to 5, turned, and went from 5 to -1. It went up, turned, came back down. Okay? Tomorrow we'll talk a little bit about rate of change, finding the rate of change on a quadratic, a linear, an absolute value. All right, on this one you plug it in, -2, -1, 0, 1, 2. You're going to get 3, 4, 5, 6, 7. And if you graph this one, it's going to be absolute value, but when I graph this, 0, 3, so this is 0, 5, 1, 6, 2, 7, -1, 4, -2, 3. All right, and if you put it in your graphing calculator, now I know that it's going to be an absolute value. I know it's going to be shaped like a V. When you use the graphing calculator, to put the absolute value bars in that y equals, hit the math key, arrow over to num, N-U-M, and you'll see number 1 is ABS. That's the absolute value. Hit enter, and it's gonna put the absolute value bars in your y equals. So then you're just gonna type it in, variable key +5, and arrow out and hit and graph, okay? And if you'll notice, this graph does like this. It makes a V, okay? Yeah, graphing calculator is wonderful on this, okay? I know you should know how to plug in numbers, so we're not gonna waste time on that. We'll let you see it here. All right, y equals 1/2 x. You put it in y equals just like it says, parentheses, 1 divided by 2, parentheses, and you do your little caret sign, which is right below clear, and hit your variable key for x. All right, so you got -2, -1, 0, 1, 2. So 4, 2, 1, 1/2, and 1/4. Okay, so when you graph it, here's 0, 1, -1, 2, -2. Let me get this bigger. A woman can't see. Okay, we got 0, 1, -2, excuse me, -1, 2, -2, 4. And then over here we've got 1 and 1/2, so it's in between there. And then 2 and 1/4, so it's right above 0. All right, all of these are going to be right above 0. They get smaller and smaller and smaller decimals, but you've got an exponential. Okay. All right, so on your homework, your classwork, whatever, depending if you're virtual or not, you're going to identify a function by its graph or its equation, and then you're going to take an equation, plug some points in, use this domain, -2, -1, 0, 1, 2. Use that calculator app or graphing calculator, plug them in and graph it. Okay? All right, thanks.